students. I hope you all are safe in the pandemic. Now let us start today's lecture. Rational number, class 7 rational number. In my last class we have already discussed about rational number. Today we continue with the operation on rational number. At first please say me, what do you mean by rational number? Rational number is the number which can be expressed in p by q form, where p and q both are integers and q not equal to 0. P and q both are integers and p and q are in the lowest form, integers, q not equal to 0, and they both are in lowest form. Lowest form means they are in simplest form, or lowest form means no common factors between p and q. Suppose I say 15 upon 5. Is this in lowest term? Is this in simplest form or lowest term? No, because they have a common factor 5. Then this is 3 upon 1. 3 upon 1 is the perfect simplest form in which there is no common factor. Suppose I say 14 upon 7. Is this in simplest form? No, because they have a common factor 7. Then 2 upon 1 is the simplest form. Suppose I say 4 upon 10. Is this a rational number? At first say me, is this a rational number? Yes, this is a rational number. But here 4 and 7 are not in simplest form. They are not in lowest term. They are common factors between 4 and 10. If I divide 4 by 2 and 10 by 5, this is 2 upon 5. 2 upon 5 is the simplest form or in the lowest term. Then this is the perfect rational numbers. Now let us discuss about operation on rational number. At first please say me the properties of addition of rational numbers. The properties of addition of rational number. The addition of rational number satisfies closure properties. Addition of rational number satisfies addition. Please students note down the important points. Rational addition, and please students do your worksheets and ask me your doubt. I promise to complete your syllabus and would like to solve all your doubts which you may drop in my comment box. Addition of rational number satisfies closure property. What do we mean by closure property? Satisfies closure property. Here the closure property means closure property. The closure property. This means suppose A upon B, C upon D are the rational numbers. This means A upon B plus C upon D is also a rational number. If this is a rational number and this is a rational number, sum of these two is also a rational number. This is the closure property. Then next the commutative property. The commutative property says that the commutative property says that suppose A upon B plus C upon D is equal to C upon D plus A upon B. This is the commutative property. Let us discuss some examples for closure property and commutative property. Examples: suppose 4 upon 5 and 2 upon 7 are two rational numbers. At first let us check whether the satisfies the closure property or not. Then 4 upon 5 plus 2 upon 7 is equal to the LCM of 7 and 5 is 35. Then this is 7 4 are 28 plus 10, which is equal to 38 upon 35. Yes, 38 upon 35 is also a rational number. This means these two satisfies the closure property. Let us discuss about the commutative property. Commutative property says that 4 upon 5 plus 2 upon 7, which is equal to 38 upon 35. Now this is LHS. Now discuss the solve the RHS. The RHS is, we have, for commutative property, we have to prove that A upon B plus C upon D is equal to C upon D plus A upon B. This means we have to prove that 4 upon 5 plus 2 upon 7 is equal to 2 upon 7 plus 4 upon 5. Then here the 4 upon 5 plus 2 upon 7 is equal to 38 upon 35. Now discussed about the RHS. 2 upon 7 plus 4 upon 5. The 35 is the LCM. Then here this is 10. 5 2 are 10 plus 28, which is equal to 38 upon 35. Then this is LHS, and here this is RHS. Yes, we get LHS is equal to RHS. This means this satisfies the commutative property. If 4 upon 5 plus 2 upon 7 is equal to 2 upon 7 plus 4 upon 5. Now let us discuss the associative property. The associative property, the third property, associative property, which says that third property, associative property. Associative property says that suppose A upon B, C upon D, E upon F are three rational numbers, then addition of associative property says that A upon B plus C upon D is equal to A upon B plus C upon D plus E upon F. This is associative property. Now let us discuss some examples. Suppose 2 upon 3, 3 upon 5, 7 upon 6 are three rational numbers. Now take the LHS. LHS is 2 upon 3 plus 3 upon 5 plus 7 upon 6. Then the RHS is 2 upon 3 plus 3 upon 5 plus 7 upon 6. Here we have to prove that LHS is equal to RHS. If the LHS is equal to RHS, this shows that this satisfies the associative property. Here let us solve the LHS. Here 2 upon 3 plus 3 upon 5, the LCM is 15. 5 2 are 10 plus 9 plus 7 upon 6, which is equal to 19 upon 15 plus 7 upon 6. Here 15 and 6, the LCM is 15 and 6, the LCM is 15, 30. 30 is the LCM, then this is 19 2 are 38 plus 7 5 are 35, which is equal to 63 upon 30. Then by dividing with 3, this is 73, this is 73 upon 30. This is 73 upon 30. This is LHS. Now let us solve the RHS. Keep it here. Now solve the RHS. Keep it here. Let us solve the RHS. The RHS says that 2 upon 3 plus 3 upon 5 plus 7 upon 6. This is equal to 2 upon 3 plus, this is LHS. When we solve, this is the answer of the LHS. Let us solve the RHS. Here the LCM of 5 and 6 is 30. Then this is 6 3 are 18 plus 35, which is equal to 2 upon 3 plus 53 upon 30. Then here the 30 is the LCM. Then this is 20 plus 53, which is equal to 73 upon 30. This is the result of RHS. Here the result of LHS. Hence we come to the conclusion that LHS is equal to RHS. This shows that the addition of rational number satisfies the associative property. At first we say this satisfies the closure property, then commutative property, then associative property. Now let us discuss about the identity property. The identity property says that 1 is the additive identity. Additive identity identity. This shows that suppose P by Q plus 1 is equal to 1 plus P by Q, which is equal to P by Q. Now let us discuss that. Now let us discuss examples in my next page. The suppose 5 upon 7 is a rational number. 5 upon 7 plus 1 is equal to 1 plus 5 upon 7, which is 0 is the additive identity. 0 is the additive identity. Suppose P by Q plus 0 is equal to 0 plus P by Q, which is equal to P by Q. 1 is the multiplicative identity. Then 1 is the multiplicative identity. 0 is the additive identity. Then which is equal to 5 upon 7. This shows that addition of rational number satisfies the identity. 0 is the additive identity. Then the fifth property says inverse property. Fifth property says inverse property. Inverse property says that addition of inverse property says that for every P upon Q there must exist a minus P upon Q such that P upon Q minus P upon Q is equal to 0. Plus minus P upon Q is equal to 0. This means suppose example says that 11 upon 13 is a rational number. For any 11 upon 13 there must exist minus 11 upon 30 such that 11 upon 30 plus minus 11 upon 13 is equal to 0. This shows that addition of rational number satisfies the inverse property. Hence, now discussed about the multiplication of rational number. The multiplication of rational number in the same way satisfies the closure property. Multiplication of closure property for multiplication of rational number. For multiplication of rational number. Multiplication of rational number. This means rational number. This means suppose A upon B, C upon D are the rational number. This shows that A upon B into C upon D is a C upon BD is also a rational numbers. Take some examples. Suppose 4 upon 5 and 7 upon 3 are two rational numbers. This shows that 4 upon 5 into 7 upon 3, which is equal to 28 upon 15, is also a rational number. Then the second property says that commutative property. Multiplicative commutative property says that commutative property for multiplication says that suppose A upon B into C upon D is equal to C upon D upon A upon B. Take some examples. 2 by 3 and 3 by 5 are two rational numbers. Then 2 upon 3 into 3 upon 5 is equal to 3 upon 5 into 2 upon 3, which is equal to 2 upon 5 is equal to 2 upon 5. This means multiplications of rational number satisfies the commutative property. A upon B plus into C upon D is equal to C upon D into A upon B. Now discussed about associative property. Let us check the associative property for multiplications. Associative property for multiplications. Associative property for multiplications. For multiplication. You students, please do your worksheet and ask me your doubt and follow my lectures regularly. I assure you there will be no need of any extra maths classes. A upon B, C upon D, E upon F are three rational numbers. The associative property says that A upon B into C upon D into E upon F is equal to A upon B into C upon D into E upon F. Now take an examples. Suppose 2 by 3 into 3 by 5 into 7 upon 2, which is equal to, now solve the LHS, which is equal to 2 upon 5 into 7 upon 2. 2 cancels, which is equal to 7 upon 5. The answer of LHS is 7 upon 5. Now solve the RHS. The RHS says that 2 upon 3 into 3 upon 5 into 7 upon 2, which is equal to 2 upon 3 into 7, 2 cancel, which is into 7 upon 1 minute. This is 3 upon 5, 2 upon 3 into 7 upon 2. 3 cancels. This is 2 upon 5 into 7 upon 2, which is 7 upon 5. Then here this is 2 upon 3 into 3 upon, this is 3 upon 5 into 7 upon 3. This is 3 into 5 into 5 into 2. Then by solving this, 2 cancels, 3 cancels, which is equal to 7 upon 5. This is the answer of LHS, and by solving the RHS, we get this is also 7 upon 5. This shows that LHS is equal to RHS, which means multiplications of rational number satisfies the associative property. Now discussed about the identity property. 1 is the multiplicative identity, 0 is the additive identity, where 1 is the for identity property. Identity property says that 1 is the multiplicative identity, which shows that suppose P upon Q belongs to the rational number P upon Q into 1 is equal to 1 into P upon Q, which is equal to P upon Q. Then this is 1 is called the multiplicative identity. Take an example. Suppose 7 upon 6 into 1 is equal to 1 into 7 upon 6, which is equal to 7 upon 6. Now let us discuss about inverse property. The inverse property says that there for additions, we says for every P by Q there must exist minus P by Q, such that P by Q plus minus P by Q is equal to 0, as 0 is the additive identity. Here 1 is the multiplicative identity. The inverse property of multiplication says that multiplication says that suppose P by Q there must exist a Q by P such that which is reciprocal of P by Q. P by Q into Q by P is equal to 1. Q cancels, P cancels. Suppose 2 upon 5 is a rational number. There must exist the reciprocal 5 upon 2 in such a manner that 2 upon 5 into 5 upon 2, 5 cancels, 2 cancels, which equal to 1. This is inverse property of multiplications. Now let us discuss about distributive property. What is distributive property says? The distributive property says that suppose sixth property, distributive property. The distributive property says that, look at here, distributive property says that suppose A by B, C by D, E by F are the rational numbers. The distributive property says that A upon B into C upon D plus E upon F is equal to A upon B into C upon D plus, here if this is plus or minus, this is also plus or minus, A upon B into E upon F. This is distributive property. Take some examples. Here we say suppose 2 by 3, suppose 3 by 5 and 7 by 10. Then the LHS says that 2 upon 3 into 3 upon 5 plus 7 upon 2, which is according to the distributive property, this must be equal to 2 upon 3 into 3 upon 5 plus 2 upon 3 into 7 upon 10. Now solve the LHS and solve the RHS. If we get LHS is equal to RHS, then we say that multiplication, then we say that the rational number satisfies the distributive property. Now let us solve the LHS. LHS says that 2 upon 3 into 3 upon 5 plus 7 upon 10, then the LCM is 10, then this is 2 2 ja 4 plus 7, which is equal to 2 upon 3 into 11 upon 10, then this is 5, which is equal to 11 upon 15. Then the RHS says that, here the RHS says that 2 upon 3 into 3 upon 5, 3 cancels, plus 2 upon 3 into 7 upon 10. Then this is 5, which is equal to 2 upon 5 plus 7 upon 15. Then here this is 15 is the LCM, 15 is the LCM. Then this is 2 3 ja 6 plus 7, which is equal to 2 3 ja 6 plus 7, which is equal to 5, 1 minute, 2 upon 3, this is 2 upon 3 into 3 upon 5, then this is 2 upon 3 into 7 upon 10, then here 2 upon 3, 3 2 ja 6, then here this is 13, then this is 13 upon 15, here is also 13 upon 15. This is the answer of the LHS. Here we get the answer of the RHS. Hence we get LHS is equal to RHS. This shows that the distributive property hence proved. Hence we proved the distributive property. The rational number satisfies the distributive property. Now let us discuss about some more examples about the rational numbers. Operation on rational number. Students, I have already told you only knowing the theory is not sufficient for a math students. Unless you practice variety of questions, then the questions which will be asked in your exam paper will be challenge for you. When you practice variety of questions, then the questions which will be asked in your exam paper will not be a challenge for you. Here the question says that find the sum. Find the sum means add. Find the sum minus 3 upon 11 minus 2 upon 7. This means the minus 3 upon 11 minus 2 upon 7. Then the 11 and 7, the LCM is 77. This is minus 33 minus 22, which is equal to minus 55 upon 77. Then this is minus 5 upon 7. This is the answer of the questions. Then now here also find the sum 7 upon minus 16 plus minus 3 upon 4. I have already told you the subtraction sign in the denominator, then take it to numerator. This is minus 7 upon 16 minus 3 upon 4. Then here this is the LCM is 16. This is minus 7 minus 12 which is equal to minus 19 upon 16. This is the answer. Now let us find the sum. Then another question is given here. Another question is find the sum of 7 upon 9 plus minus 7 upon 9. At first, please say me, what is the relations between 7 upon 9 and minus 7 upon 9? Minus 7 upon 9 is the additive inverse of 7 upon 9. Then I have already told you, for every P upon Q belongs to the rational number, there must exist an inverse minus P by Q such that P by Q plus minus P by Q is equal to 0. Here minus 7 upon 9 is the additive inverse of 7 upon 9. Then 7 upon 9 minus 7 upon 9, which is equal to 0. 0 is the additive identity. Then now the question says that find the difference between the, here another question says that subtract 2 by 5 from 3 upon 7. This shows that subtract 2 upon 5 from 3 upon 7. This means 3 upon 7 minus 2 upon 5, because we have to subtract 2 upon. At first, students, please try to understand the questions. When you understand the questions, then you can solve it. Here what the question says, subtract 2 upon 5 from 3 upon 7. This means 3 upon 7 minus 2 upon 5. Then the LCM is 35. Here this is 15 minus 14, which is equal to 1 upon 35. This is the answers. Here another question says that subtract minus 11 upon 19 from 17 upon 38. Here we have to subtract this from this. This means we have to 17 upon 38 minus of minus 11 upon 19. Then when we open the bracket, this is 17 upon 38. When we open the bracket, here is the minus sign. This means the sign will be opposite inside the bracket. Then this will be plus 11 upon 19. Then here 38 will be the LCM. Then this is 17 plus 22, which is equal to 29 upon 38. This is the answer of the questions. Now let us discuss some more examples. Here you have to prove, here we have to verify the commutative property. Here let us verify commutative property, verify commutative and associative property for the given rational number. Commutative property and associative property For the question is given here, x equal to 5 upon 7, x equal to 5 upon 7, y equal to minus 3 by 2, z equal to 11 upon 14. Then here we have to at first verify the commutative property. The commutative, according to the commutative property, x plus y will be equal to y plus x. Now let us take the LHS. 5 upon 7 plus minus 3 upon 2, which is equal to 14 is the LCM. Then this is 5 2 ja 10 minus 7 3 ja 21, which is minus 11 upon 14. Now solve the LHS. Y plus x, which means minus 3 by 2 plus 5 upon 7. Here the LCM is 14. Then this is minus 21 plus 10, which is equal to minus 11 upon 14. Here this is the LHS and this is the RHS. Means LHS is equal to RHS. Hence verified the commutative property. Hence verified the commutative property. Hence verified the commutative property. The commutative property. Now let us verify the associative property. Keep it here and verify the associative property. The associative property, to prove the associative property, we have to prove that x plus y plus z is equal to x plus y plus z. Here the x is 5 upon 7 plus y is minus 3 upon 2 plus 11 upon 14. This is the LHS. This is equal to 5 upon 7. Let it as it is, plus inside the bracket the 14 and 2. 14 is the LCM. Then this is minus 7 3 ja 21, minus 21 plus 11, which is equal to 5 upon 7 in plus 5 upon 7 plus minus 21 plus 11. This is minus 10 upon 14. Then here the 14 is the LCM. This is 10 minus 10, which is equal to 0. Now take the RHS. The RHS for associative property is x plus y plus z. Here the 5 upon 7 minus 3 by 2 plus 11 upon 14. Then this is 14 is the LCM. Then this is 5 2 ja 10 minus 21 plus 11 upon 14, which is equal to minus 11 upon 14 plus 11 upon 14. Then this cancels, which is equal to 0. Here the LHS answer is 0. Then in RHS we get 0. This shows that LHS is equal to RHS. Hence the associative property verified. Hence verified which property? Associative property. In question 1 we have proved the commutative property. We verified the commutative property. Now we verified the associative property. You students, please do your homework and ask me your doubt. I am ever ready to clear your all doubts. Now let us solve some simplifications. Here the question says that simplify. For simplifications, you know the board mass is used. This is D mass will be used, minus 3 upon 10 plus 12 upon minus 10 plus 14 upon 10. I have already told you the negative sign in the denominator is not the normal form. Take it to the numerator. Then this is 14 upon 10. Very easy. 10 is the LCM here. Then this is minus 3 minus 12 plus 14, which is equal to minus 15 plus 14 upon 10, which is equal to minus 1 upon 10. This is the answers. Now let us simplify another questions. Another question says that 5 upon 36 plus minus 7 upon 8 plus 6 upon minus 72 plus minus 3 upon minus 12. At first take it into the normal form. The normal form means denominator should be taken into the numerator and open the bracket. Then this is minus 6 upon 72. Then here minus cancels, which will be 3 upon 12. Then from these all two we can take as 72 the LCM. Then this is 5 2 ja 10 and here 72, here 8. When 8 divided by 72 we get 9. 9 7 ja minus 63 minus 6 and 12 6 ja 72. This means 3 6 ja 18. Then here we get this is minus 53 minus 6 plus 18 upon 72, which is minus 59 plus 18 upon 72, which is equal to minus 41 upon 72. This is the answer of the simplifications. Then students, today this much. In my next class we will continue with this. Till then, happy learning. Thank you students. And if you have not